Hi, everyone, and welcome to yet another award-winning episode of Cosmos with Cosmos.
Okay.
As always, I'm Mike.
I'm Liz.
And we have Smeagol, and that's it today.
And I'm Brandon. Brandon is on assignment.
He's on assignment. He's
always on assignment. I wonder when he's going to turn in these assignments, because
never.
I feel like he's way past his deadlines at this point.
Never going to do it. So today's episode actually comes to us from Liz's mom. Yeah. So, I don't know if she remembers this or not, but it does come from her. But anyways, today's episode is all about Sun Burps.
Sun Burps. Sun's very
Burps.
gassy. It's very gassy. It's got a lot of gastrointestinal issues.
Should we say it's more plasmy?
Well, we'll get into that. We'll get into that.
All right, but before we get into our son's burps and flatulence and stuff, let's go over a few things.
Okay.
All right, so first of all, let's talk about drinks. What drinks you got?
Well, thank you for asking. I am drinking...
Doing right.
I think I've already forgotten it. I am drinking Plasma Rain. Plasma Rain.
That is her best
That's my best. That's my best Prince. I think the first little bit of that song I ever heard was today, so I could do that for this drink.
And but wasn't it only because I said you do it like Purple Rain?
Yeah, and I was like, I've never actually heard it. So, yes, Plasma Rain, which sounds delightful, and it is some gold rum, cranberry juice, triple sec, lime juice, and simple syrup. So it's a nice, refreshing drink on the palate, much like Plasma Rain is.
Summery drink.
A summery drink.
Not summer.
No. What are you drinking?
I am drinking what I am calling X42, and we'll get into what in the world that means later on. But really and truly, this is, whereas Liz has the light rum, I have the dark rum and ginger beer. So also known as the dark and stormy.
That's pretty. Well, it's very bright and stormy on the sun, though.
Yes.
Like real bright.
But stormy.
Very
stormy as hell. All right, so those are our drinks. And as always, follow us on all the social media things that are out there. Was not expecting that.
I'm going to start using more props.
Drinking Cosmos on Twitter and Cosmos on really just everything else. On Instagram and so forth. So follow us on all the things, rate us on all the things, tell all your friends about us, and tell them to listen to us. And if they don't want to listen to us, strap them in a chair and play us anyway.
Just got to keep their ears open.
Yes. This is like, what was that movie? Clockwork Orange. Instead of the eyes, it's the ears. All right, and as always, a few rules, because these rules are going to come in.
Probably going to come in.
They're probably going to come in today. All right, so anytime a dog barks, so anytime puppy bark, there's a good chance that's going to happen because somebody is expecting something.
And 5:15 p.m. today.
Yeah. Also, any Star Wars reference or Lord of the Rings reference, take a drink, and if you just so feel inclined, just take a drink or not.
Yeah, do whatever you feel, what you want to do, all right? We're just here to have a good time. We're not pressuring anyone, and always drink responsibly. But my mom will be having a Cosmo later, so enjoy that Cosmo, Mom. After all that yard work you watch Dad do. It's exhausting.
We have never had one on this show.
No, we did.
We did?
We did. We had one finally I forget what episode we had it, but we were like, we're finally having one.
All right, well, we should make more.
Anyway. Oh, hold on. Jack says peach whiskey is good to make a sauce for ice cream.
Really?
Oh, Jack. God, I just want Jack to make me all the foods.
Yeah, I know, right? Or all the drinks, anyway. All right, so we're talking about Sun Burps today.
Sun Burps.
Sun's burping let's jump right into it.
Stuff all the time.
Yeah, I mean, you go out on a hot summer day, you look at the sun, and
no, don't actually.
Yeah, don't look directly at the sun. But you go out on any day, on a sunny day, and the sun just feels like it's, unchanging.
Yeah, it's just a bright ball of light in the sky.
Yeah, but it's just a roiling hot mess, is what it is.
Yeah, it's really.
It's really
literally. Gotta get it shit together.
But it's so our sun is the closest star to us, And it's a pretty active thing, really active. And, just here on Earth, we typically don't think of how active our sun is. But we're going to get into some of that today. So maybe we start off with really kind of talking about what our sun is.
Yeah, what is it? It's a star. What the fuck's a star? Which we've talked about a lot of times on this show, but if you're just joining us.
Yeah, well, our sun is a big ball of plasma. You thought I was going to say gas. It's plasma. It's plasma.
A copyright infringement incoming. The sun is a mass of superheated gas, a gigantic nuclear furnace.
Let it be known.
It's less than 30 seconds, right? It's fine.
We started this, 10 minutes ago?
Yeah.
I was wondering when that was going to come in.
Yeah, I mean, I've been singing it constantly.
All right, so plasma is this fourth kind of state of matter.
Yeah, it's just real hot gas.
It's just really hot gas.
Real hot.
It's the closest star to us at a mere 93 million miles away from us.
That's not too bad.
Has a temperature of about 10,000 degrees on its surface, but 27 million degrees in the center of it.
Oh, only 27 million?
Yep, only.
And that's just average.
Almost as hot as Phoenix during the summertime.
Yeah, or still right now, apparently.
Yeah.
It's just an average sized and
Average
temperatured star. Just, run of the mill.
Yep, it is. It has a classification of a G2 star, and it goes by the name. It's basically, they call it a yellow dwarf star, but it's really kind of more whitish in color. But that's really what it is, and it's about 4.5 billion years old. Yeah, give or take a few.
Around there somewhere.
The universe itself is about 13.8, and the most distant galaxy that we've ever seen is something like 11.2 billion.
That's old.
Yeah, which means the light that left that galaxy had been traveling for like 9 billion years before our solar system was even formed.
That's
crazy to think about, isn't it?
Oh, and another episode. All right, let's focus. Focus.
All right.
The sun.
The sun. The sun basically has 6 different parts to it.
Layers.
Yeah.
Parts.
Yeah, sections, whatever you want to call them.
Pieces.
In the very center of it, where all the energy is created, is the core. It's where all this nuclear fusion occurs.
Thermonuclear fusion.
Yes, and so the sun, what it's doing, it's converting every single second, it converts 600 million tons of hydrogen into helium.
Yeah, because the gravity and the pressures are so intense
Immense,
that it actually causes hydrogen to fuse, which we can't reproduce here on the Earth. We're unable to do it.
Don't have the energies.
We don't have the energies in order to do a fusion. So only in the cores of stars can you get nuclear fusion,
where it's hot enough and the pressures are great enough.
Yes.
But not only that, yes, it converts hydrogen and helium, but it also converts a little bit of that matter, like 4 million tons of it every second, into energy. And that energy takes about roughly 100,000 years just to get to the surface of the sun.
Just believe it's because it's getting bounced around all over the place. It doesn't have a straight shot out.
It doesn't have a straight shot. As soon as it gets created, it gets absorbed by something, and then it gets emitted and absorbed again. Right. So it takes about 100,000 years, but once it gets to the surface, it only needs 8.5 minutes to go from the sun to the earth, and that's it. And you get to feel it on your face.
8 minutes for skin cancer.
Yeah. And so that's the core where everything is happening. Then you have the radiative zone. This is where the energy is transported away from the core.
Okay, but it's radiating.
It's radiating energy. It's basically the energy is in the form of photons.
Okay.
It's in the form of light. And then you have this layer just above it called the tachyon line, and this is kind of the boundary between the radiative part of the sun and the convective part of the sun. And if you're not sure what convective heat transfer is, just go ahead, fill up a pot of water and boil it, and those bubbles.
That's convection.
That is convection. And so that's what's going on in the convective layer. The heat goes from the center, from the inside of the sun, in these huge bubbles that bubble up and take the heat with it. They just rise up, and when they get to the photosphere, they release that energy and cool, and then they get denser and go back down and repeat the whole process again. And so that is the convective zone. And
is that plasma in there?
Oh yeah, it's all plasma.
It's all plasma.
It's all plasma.
Okay.
And you can actually see those bubbles. You can see them on the surface of the sun.
Oh,
the granulation.
Yes.
There's these really cool ass pictures of the sun that has, you can see what looks like little, I don't know, it's almost like a beehive.
Okay, okay, there's a really good picture. There's super close-up images of the surface, so to speak, of the sun. And there's one image that looks like, because there's a sunspot in it, and it looks like a sunflower.
Oh.
So like Google sunflower sun image, or close-up surface of the sun picture. I don't know, but those are some of my favorite pictures of the sun. Just seeing that it's like this, like a honeycomb, but not. I don't know.
Yeah, and those in the images, they look small. Those little granulation things, but they're like as big as the United States.
Yeah,
as big as Russia. I mean, these are really big bubbles.
The sun's real big.
Huge, massive. Millionaires could fit inside of it.
Yeah. You could fit all the planets in our solar system inside the sun
600 times over. Yep.
So,
which is something we did not know.
No, we just learned that today.
Which was like, oh shit, that's cool.
I was like, damn, I never actually thought about that.
Yeah. And then right above the convective zone, you have the photosphere, and that's the part that we see and enjoy every day. Mm-hmm. It is, quote unquote, the surface of the sun. The sun doesn't really technically have a surface that you can walk upon.
Surface.
So, but this is that roiling surface of the sun.
Where we see the bubbles come up from the convective zone.
This is where you can see the sunspots and things like that. And just above it, you have the corona.
That's the sun's atmosphere.
Yeah, it is.
Basically.
Whereas the photosphere, the quote-unquote surface of the sun, is about 10,000 degrees. The corona is about 1,000,000 degrees.
Oh, it's hot. And how far does the corona extend out?
Oh, that's a good question. I don't know.
I think it's like it extends out really far. So, we can only get so close to the sun just because of the corona.
Yeah.
Is it but isn't one is it the Parker Solar Probe that is like
in it? Yeah.
In the corona, it's going to be in the corona?
Yep.
And that's our first time as the science documentary episode that we watched, first time behind enemy lines.
Oh, yeah.
And I was like, why did you choose that phrase? The sun gives us life. Like, it can also destroy us, and it will, but...
It will, yeah, so...
I was like, why is it behind enemy lines?
And it's not too far off, but it's also not necessarily correct either. And that corona is what you see on that beautiful wispiness in a total solar eclipse.
Yes.
Whether you've seen one in real life or pictures of them, it's amazing. It's amazing. But again, if you ever have a chance to see a total solar eclipse, do so. It is amazing.
My mom asks, does it only appear round, or does its gravity keep it round? And it's gravity.
It's gravity.
It's gravity.
Yeah, so when an object gets to a certain size, gravity forces it to be round. A sphere is the least energetic shape you can have. Mm-hmm. And so it's the easiest thing to make. And so when it gets to a certain size, gravity overcomes those forces that kind of keep things looking like potatoes and stuff like that, and forces it to be round. Mm-hmm. And so the sun is round. In fact, the sun is the radius from the center of the sun to the equator and the radius from the center of the sun to the pole. The only difference is 6 miles.
Wow, so it's really round.
It is really round.
Wow.
That's not so with Earth. It's not. Earth has a bigger oblateness or squashiness to it.
Yeah.
Saturn has even more. Mm-hmm. It might be the most oblate in the solar system.
Wow. Okay.
Yeah, and that's because the sun doesn't really rotate that fast. The sun rotates.
Yeah, it rotates, but not.
Yeah, and it has what's called differential rotation, which means the equator rotates faster than the poles.
Causes some good shit we're gonna get into.
Yeah. All right, so let's get into that
Yeah,
good
let's
shit.
get into the good shit. Let's get into the sun,
All right.
the sun burps and belches, and I love sun explosions.
Yeah. Yeah. All right. So and let's get into not so much the explosive part.
Yes, not yet. A little background.
Let's
a little,
save that.
What leads up to the explosion?
Yeah. Let's talk about prominences. Yes, and this was something I didn't know until I was doing some research into this episode.
Oh.
And it was first described in a 14th century Laurentian Codex about an event that occurred in May of 1185, a total solar eclipse. And it was described as a flame-like tongues of live embers coming off the moon. So they were able to see prominences. So the moon's in front of the sun, right? And you can see the corona, but these they saw these little reddish little flame-like tongues of live embers.
How did they see it?
They're being stupid. Well, I mean, it's a total solar eclipse. So what do? You go, oh, I'm gonna look at the sun and not realize that it's not the best thing for you. But even during a total solar eclipse, but I just think that's a beautiful.
That is very.
It's the first description of it, and I just think it's a beautiful description. And it was first photographed. I only put this in because of the date, July 18th, 1860.
Wow.
Yeah, so that was the first time that it was actually photographed. And they were able to see prominences on it. And with photographs, you're able to actually make measurements with these things. You're able to figure out how big they are and things like that.
That's cool.
But 8 years later, during another total solar eclipse, they discovered helium from looking at prominences. Yeah.
Wow.
They were able to pass that light through a spectrometer. I don't know how good it was in the 1860s, but it was good enough for them to discover helium.
So they're like the sun's making helium somehow.
Yeah.
How did that helium get in there?
Yeah, but at the time, this is the first time we had ever experienced helium. It was an unknown element at that time.
Oh shit! Really? So
Yeah.
It
was discovered on the sun, hence the name helium. Helios. Before it was discovered here or made here on Earth.
Think of all those people that have never experienced balloons.
Yeah.
Or inhaling helium and making your voice all squeaky.
Yeah, well, they discovered it, but then they had to figure out, where do we find this shit?
No, I just mean before.
Yeah, I know, right?
Wow, I didn't realize that the discovery of helium was really so recent.
150 years ago, roughly.
Man.
So it's discovered in a total solar eclipse by Pierre Jensen.
Helium delivered by ancient Amazon.
Oh my gosh. All right. I'm sorry. For some reason, when I read that, I had a flashback to that damned movie we watched last night.
Oh, let's not even advertise it.
Yes. No, we won't do it. But it was.
We'll just tell you this, that we were watching it as a farce because we knew it was conspiracy bullshit, and we got an hour in and we realized it was a QAnon movie, and we're like, oh my gosh, okay.
Yes.
It was so full of shit. But anyway,
and this is why Brandon is never allowed back here again, because he told us about this. This is Brandon's fault. This is Brandon's fault. I hope he's listening.
He's not.
Is he on a plane?
No, he just found his phone after losing it in a house 20 miles away yesterday. So, hence why he hasn't responded to us at all.
All right. Okay, so you've probably seen pictures of prominences. Those are beautiful loops on the surface of the sun.
They're very prominent.
I like the look to the camera. God, yeah, no. Are they really prominent?
Yeah, they're prominently
on the surface of the sun. Anyway, so you've probably seen them, and as those loops that kind of go off the surface of No, she can't help herself. Don't encourage it. They go off the surface
No
and kind of
encouragement
loop back
needed.
around. And you know what's really cool about those prominences? Why don't you tell us a little bit about your drink?
Yes. So, remember, I'm drinking Plasma Rain. Plasma Rain.
There you go. Thank you.
And so as these basically, because plasma is charged. Is that what it is? It's charged.
Well, yeah, I mean,
whatever. Yeah. It's a charged thing. I don't know. So the magnetic field lines can pull that plasma up from the surface. But then as it cools, that plasma will actually rain back down in plasma rain.
Plasma rain, so it rains on the sun.
It rains.
This is not the rain that you want here.
No, you don't.
Nope.
You
don't want it.
Just want to observe it because it'll just go right through you.
Yeah, pretty well.
Won't feel very good at all.
No, but you know, the good news is, I guess, if there's any, and there's not, in this, is that you actually will never make it to the surface. You'll be vaporized before you get to the surface. So you actually won't feel that rain.
Yeah.
You'll feel other pain, but not that rain. So, there's actually 3 different types of prominences. You have what are called active region. These are the kind of the bigger ones.
Okay.
Where there's, and it's all related to magnetic fields, and so
very
active magnetic field, active region prominences, and you have quiescent. These come from quieter regions magnetically on the surface of the sun, and then intermediate. It's just lazy writing.
Man.
It's like naming a mountain Mount Doom. Gotta take a drink.
That's by the way, did you mention Lord of the Rings and Star Wars references, or did we just get distracted by dogs?
No, I mentioned them.
Okay. I got distracted by dogs then.
So these active prominences can last hours to days. They're found in the lower latitudes, so near the equator of the sun. They're strong in what's called helium-2 lines, so ionized helium, doubly ionized helium.
I don't know what that means, but I'm just gonna nod along.
It's missing their electrons.
Oh, okay.
Both of them. They're gone.
What makes
Somebody
that work?
stole their fucking electrons.
Oh my gosh.
It's electron theft is what it is.
Jeez.
Yeah, and then so quiescents, they last longer, weeks to months. They can actually go higher above the surface of the sun than the active ones.
Really?
Yeah, but the active ones, where all the fun happens. Yeah.
Well, yeah.
The active ones, that's where you get solar flares.
Yeah, because they get all, like, tangled and shit.
Yeah, so the magnetic field lines, they get all tangled. And then, how did they describe it in the thing that we were watching? So you'll have two loops. 2 magnetic loops on the surface of the sun, and they get close to each other. And
I don't remember how they described it, so I'm
I don't
gonna
know.
keep going.
I don't know. So
you don't remember either?
They're like, hey, let's get together, and they do.
Oh yeah,
those magnetic,
like, hey,
those loops.
Hey, buddy.
Hey, buddy.
How you doing over there?
How you doing?
Yeah, you wanna meet up? Let's go get some fucking a drink or something.
Yeah, and they hook up. Literally.
Ooh.
Yes.
They hook up and it becomes explosive.
It does.
The chemistry that they have.
I know, right? So these magnetic loops, these magnetic field lines of force, these magnetic lines, where they were 2, they're now 1. And when that happens, all this energy that was pent up in those magnetic field lines gets released in the form of either a solar flare or a coronal mass ejection.
That's when they really get their rocks off.
Yeah, I know, right? So solar flares and coronal mass ejections are, they kind of originate from the same place. Not all CMEs are preceded by a solar flare, or solar flares don't follow them, that type of thing. So they don't always happen together.
Okay.
But this process is what kind of starts them off into existence. Solar flares is basically it's a sudden release of electromagnetic energy. Sudden.
Just a bam.
Bam. Now remember, these magnetic field lines, they hooked up, so orgasm of energy, I guess. So it's this sudden release, and it lasts minutes to tens of minutes.
Wow.
And so these flares can last a little bit of a long time.
Okay.
But typically they're short, and there's basically 5 classifications of them.
Okay.
ABC.
Right.
MX.
Why? Why do you do this with letters, astronomers?
I don't know. I mean, they were on a good path. ABC, just got to do D and E after that. You're good to go. But no, they're like,
No.
hey, M sounds good.
Sure.
Let's do that. It's kind of in the middle.
Yeah.
We need to represent
and
the
then
middle.
What's something dramatic for something real powerful?
X. It is complete. We're just gonna go X.
These are some
big, huge. They were probably doing like algebra or something, or ABC, and then like the astronomer helped his kid do the line for the equation for a line, which is y equals mx plus b.
Oh, I thought that was slope.
M is a slope, yes.
Oh.
But it's still in the line equation. Yeah. Ron brings up a great point. Mm-hmm. Astronomers are not English majors.
Oh, that's fair.
True.
That's fair.
That is true. That is actually one of the reasons why I went into physics. There were really 3 reasons.
There's no words. There's just letters and squiggly lines.
There were 3 reasons. The first reason was I really loved understanding the universe, and that was really the guiding principle. The second reason was there were no people. I didn't have to interact with people. You do, but I felt like I didn't have to.
Yeah.
But the third reason was I didn't have to try to figure out the mind of the artist. So no English. I wasn't going to have to read The Count of Monte Cristo and try to figure out, all the internal meanings of it. So I could just do that on my own. There's been a lot of really large flares that have occurred.
I would think there's been a lot with the sun being 4.5 billion years old. That it's got a whole history of, activity.
Yeah, one of them happened near your birthday, but in 1859.
Oh, really?
Yeah,
oh, September 1st, 1859.
It is called the Carrington Event.
Oh.
Yeah.
Oh. Okay, I think I know what happened here. Continue.
Okay.
I've heard of this.
All right, so the Carrington Event was a huge X50, so massive. When you're getting into the X's, these are big solar flares. A's are little baby ones. B's are a little bit bigger. These are toddlers. C's are teenagers. M's are just angry adults. And X ones are mass murderers.
Meanwhile, these are all just a ridiculous amount of nuclear bombs.
Yes.
Equivalences.
Yeah. Yeah. What is it? Like thousands, millions of Hiroshima nuclear bombs going off.
Yeah. So these are big bada booms, if you will.
So on September 1st of 1859, the biggest one in recorded history occurred. It's the Carrington Event. And it was an X50 flare, so massive. And
let me guess, it was headed straight for us.
It was.
Uh-oh.
And what was really cool about this event was they saw it happen.
They saw it?
Yeah, so I don't know how they were able to see it.
Wow.
But they saw it. And one day later, the Northern Lights lit up, and they made the connection between the sun and the earth and those Northern Lights.
Oh, wow.
That was the first time they made those.
That was the first time that it was like, oh.
Yeah, because not only was this a flare, it was also a coronal mass ejection. Oof. And that's what's going to cause the Northern Lights. But that is why this is such an amazing event. Mm-hmm. Not only in size and scope, but also what we were able to
learn from it
just the very next night. So, Fifth Element.
Yeah, I always make a Fifth Element reference.
Yeah.
Love it. Did it have any effect on anybody on Earth or on anything?
They can.
Yes. Like, if they had our technology in space right now, that would fuck some shit up.
That would fuck some shit up. You don't want to have solar flare. Well, solar flares is and just a shit ton of
energy
just
headed
of
straight
radiation.
for you.
So who do we have? We start the show every single day. Every single time with the video of ISS. They are sitting ducks up there. They're absorbing a lot of that radiation, and so it can be deadly.
Yeah.
It can cause some serious health issues. Now, the good news for us here on the ground that will never, unfortunately, make it to space is that we are at the bottom of an ocean of an atmosphere.
Yeah, we're pretty protected.
And it protects us. And the magnetic field of the Earth protects us from the
the astronauts, if one happened, and all the astronauts, they could get superpowers instead of die of cancer.
One would hope.
Yeah.
But they're probably gonna end up like the Hulk, though.
Oh yeah,
because
there's a lot of gamma.
Yeah,
a lot of gamma coming your way.
Yeah. So but these can also damage. Especially when you start factoring in CMEs, the coronal mass ejections. These can damage the electrical grid. In fact, there have been blackouts caused by CMEs that have occurred.
Oh, right.
Like there was that one time in the
in
Northeast that just took out all of like New York and the East Coast
or something.
It was like in our lifetime.
Oh, was it?
Yeah.
Okay.
Early aughts. Late 1990s. But they can also damage the electronics in spacecraft, and and of course, we talked about what it could do to astronauts that are up there, and so like I'm involved or not. Scientists are they are watching the sun, trying to with spacecraft. Hey, there's a CME happen. This is what you electrical companies need to do to protect your electrical grids. Astronauts, you're on your own.
Yeah.
You signed up for this.
Yeah, but we have all sides, the whole surface of the sun. Every part of the sun we can see, we're observing with numerous spacecrafts that we have sent out there, and so we can get that warning, and then that way we can minimize the bad effects that can happen. With enough fair warning.
Yeah.
People can power down their satellites or turn off what the important shit on it is, under safe mode. I don't know, whatever they do.
Yeah, smart people got that stuff.
Astronauts, I don't know, get behind. Maybe they have like those like fire warm blankets, those fireproof blankets, and they can cover themselves with like. Like when you wear that thing when you get an X-ray at the dentist, that heavy ass fucking thing that they just throw on you.
Yeah, so it doesn't mess up your eggs and stuff.
So it doesn't. Yeah. Maybe the astronaut they should have like one of those they can just throw on, protect themselves from those. Because as Jack points out, they don't issue purple shorts for astronauts.
No. So NASA's got it figured out. And the good news is, astronauts really, they are up underneath the protective magnetic field of the Earth, and so at least for the CMEs, they will miss a lot of that, but they are still going to get a little bit of radioactive dosing. And actually, it's not just the astronauts. If you are flying in a high altitude plane. You actually could get
a little dose of radiation.
What's
a high altitude plane? Is that like flying just in your 747 over?
In my head, yes, that's what it is. It's probably something like one of the military planes.
Oh yeah.
But to me, it's like every time I go up in a 747, just getting cancer. That's what I'm getting. So, but we've talked about CMEs, but. We've mentioned them, I should say. So coronal mass ejections, whereas solar flares is radiation that's going out into the universe. Coronal mass ejections, and this is the burp, is matter that gets thrown out into, burped out into the
actual
universe.
matter.
Yeah. So protons and electrons typically is what it is. These are high energy protons and electrons, so they're moving quick. They're moving fast. Electrons faster than the protons because they be lighter. And CMEs, frequency-wise, if it is during a solar maximum, the solar maximum happens, it's like every 11 years?
Yeah, so basically, we mentioned earlier that the sun has differential rotation. So it rotates faster around the equator than it does the poles, right? Or do I have it?
Faster around the equator, yes, you're right.
Okay. Yes. And so basically what ends up happening is the magnetic field lines from the sun, so they go out the north and south pole of the sun, as that differential rotation happens, those magnetic field lines start to get all twisted up and tangled up. And the more twisted and tangled they get, then the more activity that you have on the sun, and so you get you reach maximum, but then every 11 years the sun's poles actually flip. And so then what ends up happening, because the poles flip, the sun unwinds itself and it gets quieter and more chill and isn't as stressed out until the poles flip again, and then they start fucking
until it winds back up.
It winds back up.
Yeah, and so when you have that maximum occur, actually, hold on, I wanna address something that your sister says. So Katie says that hopefully she'll be dead by the next time the next Carrington event has happened. Unfortunately, there's at least been a few in your lifetime. And so.
Oh yeah, so you're fine, Katie.
You're fine. November 4th of 2003, there was an X-45.
Ooh, was it 47 or 45? Was it 45?
Yeah, it was 40.
Okay.
Okay, well, it was either 47 or 45.
Okay.
And so they happen on a regular basis. In fact, when we're at our maximum with solar activity, you get flares and coronal mass ejections that happen 3 times a day. So quite a bit. And then its minimum might happen once every 5 days.
Yeah.
Yeah. And so these particles leave the sun at over 300 miles per second. That's pretty fast. That's actually really fast.
It's really fast.
It's really fast. It means it takes 10 seconds to go across the U.S.
Wow.
Yeah,
wow.
And that's it. That means it would actually take 3.5 days at that speed to go from the sun to here. So that gives astronauts about 3.5 days to prepare if they're on ISS.
Wow.
Electrical companies to get their shit in order.
That seems like plenty of time.
Isn't it though? I mean,
I feel like if you have something in space, if you've spent the money to put something in space, that you are gonna have your safeguards for
plans.
Anything that's gonna fuck with that shit in space.
Yeah, you got contingency plans.
That's not cheap, putting anything in space.
No. But yeah, no, 3.5 days is, it's a good chunk of time, but also not a lot of time. But also remember, those are averages. So sometimes there'll be faster particles coming your way, and so you have shorter amount of time. Sometimes they're slower. They just happy to be here,
they're just
they're just going to take their time.
We're on vacation. We thought we'd just take a little jaunt through the solar system.
Yeah, and out into the universe. Why not?
Yeah, just a nice leisurely drive.
And when the sun does do this burp, it averages a loss of 3.5 trillion pounds of mass. And the sun doesn't even feel it. Doesn't even feel it. There is so much mass and matter inside the sun.
What percentage of the sun's mass is that?
Oh, it's it's absolutely nothing.
Wow. Imagine just burping, you lose a little weight.
3.5 trillion pounds of weight.
I could just burp and be like, oh, there goes that cheeseburger I ate earlier.
Yeah.
Cool. What are you doing? Is it a CME?
No, I raised my foot, accidentally hit I raised my foot. It accidentally hit the table that holds the TV, the monitor that we're watching, and it shook. And I didn't hit this one.
I know.
So, cool. So, the sun's burping all over the place.
Man, it's really...
But you
it's
know
really
those burps?
active.
Those burps is what makes those northern lights.
Yes. As those high energy particles interact with the nitrogen and oxygen in our atmosphere, we get pretty colors. And we go, ooh, pretty colors.
I really wanted to say that one day. Actually, underneath them.
Yeah.
Oh, that would be really
colors.
nice. But yeah, it creates our northern and southern lights. And you know, for me, it's just intuitive that the northern and southern lights occur in pairs at the same time.
Mm-hmm.
That had to be proven.
Well, because they follow the magnetic field lines, so they're gonna go to the North and the South Pole.
Right, but it's easy for us to conceptually see.
Yeah.
And say, but then with the way science works, is you have to prove that.
That's true.
And so they have actually sent 2 planes at the same time.
To go and be like...
Yeah, and so one's at the North Pole and one's at the South Pole, and they measure them, and they find that they are connected.
That's cool.
Yeah, and so, so the sun, sure, it makes life miserable in Phoenix. No need to live there. And it warms our days, grows our crops for us, helps grow our crops. But it's gassy.
It's real gassy.
It's gassy.
Real plasming.
And that gas can cause some problems.
Mm-hmm.
But damn if it doesn't make some beautiful stuff. These...
Space is deadly but beautiful.
Tongue-like embers of flame. Mm. The northern lights, the prominences, even solar flares are beautiful. I mean, it's just the flashes of light that occur. The CMEs, where you can actually see them erupt off the surface of the sun.
It's like sun vomit, just a spewing sun vomit.
It is actually, isn't it?
That didn't make it go with the picturesque description that you were going for, but...
No, but also what's really cool is if you watch some of these explosions on the sun, whether they are solar flares or CMEs.
Them. Oh my god.
You can see the shockwave emanate out.
Yeah.
And it's just an amazing thing to see.
Mm-hmm.
So.
Maybe the CMEs are kind of like it's burping, but when you get a little acid reflux, it kind of comes up. You know, and it's like, oh God, oh, shouldn't have eaten those hot Cheetos.
Yeah. Do we have any of those left?
No, I ate them all.
Okay. We had some.
All right.
I did eat 3/4 of it, though.
Yeah, you did.
So, all right. Anything else you want to add?
Just look up the images. Look up coronal mass ejection, prominences of the sun, and you'll be able to see that we take images of the sun in varying wavelengths of light. And so by doing that, we can actually see different things that are happening. Whereas if we just looked at the sun itself without any special technologies, we wouldn't really be able to see any of this happening. It could be invisible to our eyes, really, seeing, all the activity and the basically the convection and all that stuff happening. So we've employed a lot of different technologies to be able to observe and study our sun. And so Google the shit out of it, because those images are fantastical.
Yeah. Soho. This is Soho.
Well, you can do Soho,
SDO, the Solar
Dynamics Observatory. Soho is the Solar Heliospheric Observatory.
Yeah, you say it with confidence, and then Parker. I don't know if Parker's taken any pictures of it yet, but Parker's going to give us. And there's a whole host of other.
Spacecraft.
And actually there's a spacecraft at Mars that's also watching the sun, Maven.
Oh.
From India, the India spacecraft.
Oh, really? Okay.
Yeah.
That's
so
cool. My mom asks, does the sun affect other planets in some way?
Yeah. Are you talking about like in our solar system? So if in our solar system, yes, it affects all of them in our solar system.
They're all under the influence of the sun.
Yes, and so there are great pictures of Jupiter and Saturn with its northern lights. Yep, with its aurora. So the same thing that's creating aurora here on Earth is actually impacting Jupiter and Saturn, which have even stronger magnetic fields. They really are able to capture those charged particles from the sun. But even way out in the far reaches, like Pluto. Pluto is affected by the sun. The sun is really quite small in the Pluto sky. It doesn't receive a whole lot of warmth from the sun because Pluto is about 400 degrees below zero.
It's a ball of ice.
It is a ball of ice, but the sun still warms it a little bit. And
enough to where as it gets closer to the sun in its orbit, it gets heated enough where some of its surface ice sublimates, turns into a gas, and the solar wind pushes that gas away from Pluto, and so Pluto gets a tail like a comet.
And that's really what it is. Big old comet. Biggest comets.
I love it. It's one of the oddities of Pluto.
Yeah, so the sun definitely holds sway. In the solar system, it affects everything.
It holds us all together.
Holds us all. Yeah. There's not a single planet. There's not a single object in our solar system that's not affected by the sun in some kind of way.
After all, the sun is 98% of the mass of our entire solar system. It is the solar system. We're just little specks hanging out with it.
Pretty much, yes. The sun really does not even feel the planets in the solar system. It does, but it doesn't at the same time.
Yeah, it's like, when we have all those like fucking mites all over us, we don't feel them.
Yeah.
But maybe occasionally you get like a little itch or something, you're like, is that a mite?
Yeah. So if the planets in the solar system, if everything in the solar system were to just fly off, the sun really wouldn't feel it.
Aww.
Yeah, I know, right? And that's a crazy thing to think about. But if the sun were to disappear, we would just fly off into the universe. We'd be so fucked. Is what we would.
Yeah. Like the little cleaner fish on the sharks.
Yes, that's what we are.
The sharks don't give a shit
about them. We're the little sucker fish.
Yeah.
It's a symbiotic relationship. It's not really symbiotic for...
It's a little one-sided.
It's one-sided.
Yeah.
Anything else you want to add about before we get into future episodes?
Oh, are we going over to the Hangover? Oh no, we gotta talk about future episodes here first, and then we'll do the Hangover.
Then we'll do the Hangover.
Okay, like how we're planning out the whole show right now. Okay, cool.
Yeah. All right. So, if you have any questions about Prominences
and more sun stuff, we will talk more about that in the Hangover.
Yeah. But coming up, we actually have done some professional shit.
We've planned some things out in advance. Look at us.
We did. All right. So, because of Thanksgiving, we're kind of changing up the schedule a little bit.
Yes.
And so. Normally, we would have an episode 2 weeks from now, but we are going to have an episode next week. And that is going to be our Thanksgiving episode. So our next episode is going to be November 21st. Mm-hmm. So please join us. And it is going to be the astronomers and the universe of the first Thanksgiving. Yeah. So we're going to go back in time. Yeah. We're going to see...
What were people looking at? What were they doing? What discoveries were happening?
Yeah. What did we think of the universe? How many moons did Jupiter have? Was it just 4? Did we even know there was a Jupiter?
Oh, we did. We've known for a long time there's a Jupiter, but
we didn't know there was Uranus.
Oh, well, don't spoil it. Let's not.
Okay. At least I don't think we did. Maybe we did.
Save it for the episode, but also on that next episode.
Oh, we will have a special guest. So please join us as we have a special guest. And they will be dressed as a pilgrim.
I can see that. Actually, this guest could pull that off, actually, probably pretty well.
They don't know it yet, but that's how they have to dress. All right. And then on the 5th of December, because then we'll just do every 2 weeks because of Christmas as well, we're going to talk about telescopes.
Yeah, all the different kind of telescopes that we sent out there. and what they've done and cool shit there in preparation for
James Webb, the launch of James Webb. So on December 18th. Now, here's the thing. This is going to happen at 5:20 in the morning.
the James Webb space launch.
For us, 5:20 in the morning for us here in Utah. So your family, you can get up at 4:20 in the morning and join us because we are going to have a James Webb launch pajama party. Is it pajama or pajama?
Well, either way, I think pajama, tomato, tomatoes.
We're going to be in our pajamas.
Oh my god!
And we're going to have a party.
I just remember what I'm going to wear. Okay, cool. I'm excited now.
So that's 7:20 Eastern time, and so for Jack and Ron, if you want to join us, it's just 6:20 in the morning.
On a Saturday.
You're fine. You can take a nap later.
Yeah, exactly.
And on the 19th, we will have our regular podcast.
Yeah, for those of you who don't want to wake up for the launch.
So if you don't want to wake up and join us for the pajama party, then you can join us on the 19th for
a little recap.
A James Webb recap. And it'll either be good news or bad news.
Yeah.
Let's hope for the good news. And then on January 2nd, 2022, it's the start of a new year filled with optimism and hope that will be soon dashed, crushed, and destroyed by a new year.
Oh, boy.
Adam
says that he thinks the show Bananas in Pajamas answer that age-old question. But is it bananas in pajamas, Adam?
Yeah, you see, you can go either way. You can go all kinds of...
Anyway. Thanks for joining us on this episode of Cosmos with Sun Burps. Sun gas explosions. That happen. Stick around for the hangover. Otherwise, follow us on all the things.
All the things. Twitter, Instagram... Was it Cosmos on most everything, but Drinking Cosmos on Twitter. Like us, tell all your friends, and have them like us, whether they want to or not. And we will see you in a few minutes, or we'll see you in a week.
Yeah, thanks for joining us.
Bye, everybody.